Okay, so welcome everybody to the October user group, Boston user group. Today we have Marc Luescher talking to us about how to integrate REST and other sources into Splunk. So take it away, Marc.
Okay, well, happy lunchtime, everybody. So during today's presentation, I want to briefly cover a few areas. First, what is the issue? A quick introduction, what HEC does, what REST does, what SOAP is. Then how you would integrate a system which does not really have any Splunk app or an outdated one or one which no longer works. What are your options? And I think the most interesting part will be like a real-time example. How do you dissect a system you want to integrate? What are the options and how you go about it? So 12 slides with a lot of text and then hopefully 30 minutes demo. About me. So I'm what I think they call the product owner and lead architect of SIEM and SOAR at Fresenius Medical Care. We are in the healthcare area, in the renal area. We have 320,000 employees worldwide, and we are almost in every country. I'm not a long-time Splunker. I think I did a 0 to 100 in the last 2 years. We have an interesting hybrid on-prem AWS cloud and Splunk cloud architecture in every region of the world. And we are using federated search on top to consolidate all that information for enterprise security. We have a lot of syslog traffic. We have about 4,000 plus universal forwarders. We archive all our raw data to S3 and then ingest the data from AWS S3 into Splunk. We have about 100 indexes. We average between 90 and 360 days of retention. One only exception, which is email data. Email data needs to be kept for 6 years. Our main users of Splunk are cloud operations, network security, network engineering, and definitely our SOC. I am the father of 4 kids, 3 dogs, 3 cats, 8 hens, and a rooster. So if you hear background noise, that's Mr. Rooster. What is the issue? There are many new systems out there which do not yet or no longer have a supported Splunk add-on or application. Unfortunately, with Splunk's change from the old Python release to the new Python release and enforcement now in the latest A2 releases, a lot of applications which used to work in Splunk 8 no longer are working or are no longer supported. There are also many systems, and I would call them major players, which do not think they have the need to develop a Splunk application, or they say we no longer want to build an application just for one SIEM. We want to have an approach which will work with all other SIEM products as well. While 2-3 years ago, pretty much every vendor wanted to have a Splunk app, today they just try to find a way to get data in as many SIEMs as possible. The goal of that presentation today is to show you some more common and some, I call them more wild ways, how you can integrate such systems. Prior to taking ownership at Splunk at Fresenius Medical Care, I never touched any APIs. So for me also, I would say the last 6 months was a very hard learning curve. how do you get systems integrated. Hack Primer. The HTTP event collector is very fast and efficient way to send data to Splunk Enterprise and the Splunk Cloud Platform. Whenever possible for us, we try to leverage Hack to Splunk Cloud. It's fast, it's robust, and it just allows us extremely fast onboarding of data. There is one comment I want to make, and it took us about 6 months to find out. The Hack implementation in the 8 code stream is broken and is only single-threaded. No matter what you configure in your output conf, you only have one single thread. This will be fixed in Splunk 8.2.3, I was told. That's when you get performance back. But before, keep that in mind. If you don't get the performance you expect to see, or you have an extremely high amount of events, and your server listening to Hack is having issues, this is the reason. REST API or RESTful API. It's pretty much a newer way of integrating with backend systems and architectures using HTTP requests to get, that means to read, to update, to create, or to delete data in a given API. An API, and everybody probably knows about it, is a very abstract interface to some functions of an application. A REST API is pretty much a stateful representation of that API. The newer APIs are REST APIs. The challenge, a REST API very often is only exposed to the most common and the most needed API functions. If you need something to go a little bit deeper, then you need to use the SOAP API. And the SOAP API is what I would call the more classical API. And all major players usually have a SOAP API. It allows you to get data in and out in a structured and very formalized way. And I like that analogy here. It's like the postal service. It provides a reliable and trusted way to send and receive messages between systems. It's older, established, very well understood, but has also some limitations. Web Service Description Language, WSDL. WSDL is pretty much, call it like the description of a SOAP API in text form. It pretty much tells a calling system what it can do with a certain API, how a request needs to be built, and what responses to expect. If we now need to integrate a system, how are we approaching it? So first, we check one more time Splunk base if a Splunk add-on or app was posted in the meantime, or if an older archived application exists. Why would I want to look for an older archived application? In an older archived application, you get some very good ideas of what data can be displayed in a dashboard. And you also get a good understanding of the field names and how the fields can be extracted from the raw data. What you will see with a lot of the applications is some of them were SOAP applications before. They are now changing to REST applications. And a lot of applications before used any data stream and are changing now over to the JSON format. So while you might still be able to use some of the old applications, you might need to do a lot of data conversion and dashboard conversion, but better do that than start from scratch. For the few of us which are Splunk Cloud customers, make sure the add-on or app are vetted for Splunk Cloud. I would say good 70% of the applications are currently vetted. If they're not vetted, a customer can request the vetting process and the exception process, but there are still some deeper or lower level applications which cannot be run today in Splunk Cloud. Our third step is we usually reach out to the system vendor and ask about plans for Splunk or a more generic SIM integration options, what they have. And sometimes you get answers like, oh, we can do syslog. Oh, great. You will get the data, but you need to do a lot of manipulating, or you get answers now, we have an API and we no longer provide any applications. We think the customers are now enabled enough so they can take care. One of the examples where we had to do that was as an example with Aruba, or now HP. In order to connect their cloud gateways to Splunk, we had to work with them to build an interface inside their product to get data into Splunk. Step number 4, pick the easiest integration option. And for me, that means if you have any way of pushing the data to your environment, try to push your data. If that option is not available, see if there is a REST API which does exist and allows you to pull the data from your heavy forwarders or your IDM into Splunk. If the REST API does not exist or does not give you the granularity which is needed, then you need to look if there's an older SOAP API available. And if a SOAP API, check if a corresponding WSDL does exist. A lot of buzzwords, but I will show you in the demo exactly what I mean and what that demonstrates. Once you have an understanding how you can get the data, if you're using APIs, you should prototype your connectivity with one of the 3 tools here. There are many others on the market, but those are the ones you will find the most support from the business side. Those tools are Swagger, Postman, or if you are in the SOAP world, it's called the SOAP UI. What those tools allow you, they allow you to deconstruct the APIs and show you exactly what data you need to send to the system and what your expected results will be. But more about that in the demo. Step number 8, build out the script app or framework. Script, pretty much once you understand how the requests need to look like first request is get me a token, second request is give me a list of all the devices, third request, give me information about all the devices returned in step number 2. That's something you can pretty much do with 3 curl commands in a shell script, and you will be done. If you need to do a little bit more complex error checking and so on, then you probably should consider an application. Once you have done that for many, many times, then you will realize, I don't want to build an application for each API request. I want to use a framework. And there are some Splunk frameworks out there which can help you with that. REST API integration. And all I can say, there is currently an industry trend going on where old or experienced Splunkers leave Splunk and create their own company. In my opinion, some of that company worked on the Splunk internal REST API integration, and they founded a company called Baboon Bones. Baboon Bones is, in my opinion, the leading framework if you want to integrate any system using REST API to Splunk. Our old way of using REST API was we did prototyping with Swagger, Postman, and curl scripts. We scripted it in Bash or Python. We tried to find a way how to manage the secure username, passwords, and credentials required for every system in a secure place. The compromise at the end was, yeah, we store them all in a directory on the heavy forwarder because there are only a few admins which have access to it. But is that really secure? Rather not. REST API is also evolving. That means newer authentication standards are being used, like OS2 and so on, and bearer tokens. More about that in a bit. But managing credentials in REST becomes more and more challenging. Managing them in a secure way is even more challenging. And unfortunately, with every API call, sometimes there will be errors, like system being down for maintenance or a firewall blocking traffic, which was not there before, or whatever. That means you need to think about an error handler. Our new way was pretty much, we are still doing the prototyping, and I will show in the demo what that really means. But we use now the Baboon Bones REST API modular input just to take off a lot of the administration and management. If you look at Splunk Base, I think that's one of the leading applications with almost 40,000 downloads. So it's a very good tool, and you can expect new releases like every other week. So they really take care of it. The best, in my opinion, is they have one of the best support organizations. You can approach them with any REST API question, and you can be sure you get an answer within 24 hours on how to do it with their tool. SOAP API. Our old way with SOAP was even more painful because the SOAP API has what I called that web service definition files, WSDL files, and also a SOAP API uses a unencrypted username and password to authenticate against the system. It's very delicate to find a good way how you can secure those usernames and passwords, because unfortunately, they give you extremely high privileges in the application framework or system you want to integrate. Also, the SOAP API, since it's a little bit older, we run into, I would say, a bit more error conditions due to timing, due to timeouts, due to system temporarily not being available. So managing error conditions using the SOAP API was a little bit more challenging. Our new way was, we are still doing prototyping with SOAP UI, which is pretty much a small desktop-based application allowing you to read in those WSDL files and then send it to your target system and see what kind of response you're getting back. But we felt like the whole management of passwords and WSDL files was extremely painful. So we reached out to Baboon Bones and said, we need you to write us an application which pretty much gives us similar functionality than what you have done in REST API, but for the older SOAP API and WSDL file. And I would say after about 3 months of designing, testing, and so on, we got our first release of that application about 6 weeks ago. And we are leveraging it now with at least integration to our Workday system. I told initially 12 slides. So the next step is I will exit PowerPoint and run you through some of the approaches I have highlighted here, what that means in real life, and how some of the tools are really looking. Are there any questions before I start?
While you're starting up, I had a question. I'm assuming the REST API modular input, that access to be able to invoke that can be controlled through roles in Splunk.
So the access can be controlled through roles in Splunk. Out of the box, that's not very well done, but it pretty much, it can be configured with a few modifications.
Okay.
So I want to show now an example of where we worked together with Aruba, which is now Hewlett-Packard, to first of all understand what is possible, and secondly help HP to define an interface, how we can get the initial data into our Splunk environment. I guess I waited too long, so now we will have the fun of logging in probably everywhere again. Okay. So I mentioned initially that there are multiple ways to test a REST API. Postman being one of the most prominent one, but I personally prefer Swagger. Unfortunately, not every vendor supports a Swagger interface, but I would say Swagger is nothing else than try our API so you understand what it can do for you. In Aruba, And something you need to know about an API is you need to pretty much give an API a token. And I quickly want to show how you get a token. It's usually in an API function. And in an API function, you, first of all, you get a URL which tells you where you need to go to the API interface. And secondly, those are all mine, just a moment. Secondly, then you need to create an API key, which is what I call a Swagger token. The API key in that case is not assigned to my user ID because I still want the Splunk integration to work when I'm leaving the company. So I'm not tying it to my user ID, I'm tying it to a system account. So Splunk integration will always work. Then the client secret displayed here is pretty much the key I had to copy into my token. And now what I can do is I see here the API reference. Those are all the calls, the API calls, which are currently exposed in REST API, which can be accessed via Swagger. And now let's look for, let's say, gateway. Now I can say, okay, I'm interested in the gateway list API call. I see the gateway list API call would be called, it's a get call, REST API call get. And that's the call which is internally used. Then it allows me multiple parameters, groups, labels, and so on. I picked that one because I can just say, I don't know any of that. I want to test this input and say, try. What I now see is I get a response which shows me that is the request I would need to send to the endpoint, which is pretty much showing where to get that information. And then you see the response body. And I'm now just taking one serial number. And you see more information about that gateway. Is it healthy? Where is it connecting to? And so on. And at the end of the string, you see a response code 200. That means I got a valid response. That is important for the error handler, because you pretty much need to say, if I get a response code 200, that is fine. If I get a response 401, try again. If it's a 500, the server is down, and so on. Then the response header, it pretty much shows you how the data is coming back. Here you see it's coming back as JSON. If we go back one more time, come on. You will see here on the bottom, you also have the option sometimes that the response time should not be JSON. But as you could see, even HP no longer allows text. And the reason for it is just the responses are getting too long. That means if it's a text blob and it's over 2K, then you get multiple packages back and you need to put them back together. With JSON, that will not happen. Now I had my gateway list, and now I can go into the gateway details, like the next call. And you see here, I had to put in a serial number. That was a mandatory request. And now I can try it again. But you also see here the response messages. So you can clearly see how you need to modify your code depending on what response message you're getting back. If you do now try again, you will see, okay, now I get details for that gateway. And the nice thing about the Swagger interface, it gives you exactly how that query should be constructed if you want to send that query within a shell script or an easy Python application. And that way you can then drill deeper and deeper into what is exposed in the API. Now let me see how I can get to the next screen. Usually for every vendor, if you search for your vendor and you look for API Swagger, it will usually tell you if a Swagger interface is available and how to get there and what you should know. If we look now at the case of Aruba, you will see, okay, they allow REST API. They allow webhooks. They have a streaming API, Ansible, and Python. So there are many, many integration options. What we did at the end with Aruba is we said we no longer want to use syslog data because Aruba Central is a cloud-based service. And we did not feel that sending from a cloud-based service syslog information back to our on-prem environment so we can send it back to the Splunk cloud would be good use of resources. So what we did is we worked with HP, and now let's see if that works. And we said we want to start with some security services. And we want to get all the IDS, IPS data into Splunk. So we have worked with them and we built a SIEM integration. Yes, something went wrong. So that's why we are still working on it. But people which are aware of the hack will see that we have now a direct interface to Splunk Cloud. We are writing directly to our hack interface in Splunk Cloud. We are writing to the Aruba index with the following hack token. And before it worked, and it still works now, that means we are getting live data inside Splunk. So how does that look? Go away here. Let's open another window, might be faster. We saw before Aruba data is coming in the JSON format. That means if we run pretty much Aruba data now, you will see if you look at a transaction, it's a JSON formatted, response. And all you need to do afterwards is pretty much export or extract the fields. Because it's JSON, it's usually already done for you. So you just need to use the fields and build your corresponding views, searches, alerts, and dashboards. If we go back in the overview, our approach is we don't want to copy what we get currently already within the tools. We only want to look at the security components and the availability components. That means the IDS, IPS components. But you have seen before in Swagger that if I want to have all the information besides IDS and IPS, I can get all the raw events and I can put them down. Sometimes you see in the Swagger definitions that they want to depreciate it because they feel the API calls are too intensive for the platform. Like the list events in our environment returns about 300,000 events per minute. That really hits a lot of API limitations. So what they usually do is they come up with another way of doing it. And Aruba's way, instead of using the REST API, they say they want you to use a webhook where you pretty much send a web report to Splunk, which has all the results like every 5 minutes, and then you're just ingesting it. That is one of the examples which I could show with Aruba. Let's close a few windows. Now, the second example I want to show is one of the most common HR applications, which is Workday. And Workday for me was pretty much when I was asked to make something happen which did not exist out of the box. So I mentioned before that most application vendors have a REST API and they have what they call the web services. Web services is WSDL, but web services mainly means SOAP. Those are the two things you should remember. So our approach first was, well, is there an application in Splunk base? And I have to say, bummer, because I got pretty angry because suddenly there is one. And that's the Workday add-on, which allows you to monitor some of the security events. If you debug that application a little bit further, you will see that it's using the REST API. It uses certain bearer tokens. It uses OAuth. So we went back into Workday REST and had a look, which API are they using? And you see one of the phenomenal thing of Workday, it has about 100 different APIs. And I think there is one at the end, which is called, not performance person, no, privacy. So we found out that the privacy API had the information we wanted to get. You see again a similar endpoint as you have seen before in Aruba, get activity log. Now what is a little bit interesting here is they have provided an open API schema, which means they are very well documented. But what helps you here is, let me open it. What allows you to do it is, first of all, it shows you, oh, it's also exposed in Swagger. That means Workday also has such an interface. It shows you exactly how the different tags are being called. It shows you the field names it's pulling from Workday. And what is the most interesting is coming at the end. It gives you also the expected responses, the non-expected responses, so what you need to do in error management. But what is most interesting is all at the bottom, you will get a sample data set which shows you the JSON structure you will get later on in Splunk with system account, type, example. You know, there will be a field system account, activity action, request time, user agent, task ID, and so on and so on. So let's have a look now quickly in Splunk, how that would look. And that's the part where we probably need some editing. So you see again a highlighted record, and you see exactly the fields which I have shown you in the API specification. And you can see we have a read user from a desktop with that IP address. That is the login account, and we can see exactly what the user was doing. But the request from our ISO was, we want to know who is logging in, who is trying to log in. And the REST API, unfortunately, only shows us who was successfully able to log in. But the information our SOC was interested is who is trying to penetrate our system, who is trying to log in. So we went back into SoapLand, and you will see that there is a WSDL, which is called identity management. So if you click on identity management, and you can also download the WSDL file and the XML file here. If you click on identity management, you will see there are two main APIs available. One is get Workday account sign-ons. But in addition to the REST API, that also gives sign-on attempts. That means here we would also get the information of who is trying to log in. And the other one is unidentified sign-ons. If somebody tries to brute force our Workday instance, that API would get triggered, and it would at least give us an IP address, which is permanently trying to hit our environment, so we can block it automatically in our web application firewalls. If we now go into SoapLand, and now let me see, I think we have pretty much the SOAP application I mentioned before, but before I'm doing that, I quickly want to show you the SOAP UI, so you understand what the SOAP UI would give you. And the SOAP UI is a free web product, and pretty much it allows you to create a project. The project here I called is our test system for Workday. Then it asks you which WSDL you want to import. So you see again the two WSDLs I have shown before, get unidentified sign-ins and get Workday account sign-ons. It then asks for some additional data, which I'm not sharing, but it's the login URL, the username and the password. Then you can pretty much say, I'm interested currently in the account sign-on. So you click on the request form and you say, show me the first request. And now you will see live data from our test environment. So some login failed because that was fine. Username password was the authentication type. And that one worked as well. That one worked as well. but similar pretty much to what I've shown with REST and Swagger, you can also activate here what they call the HTTP proxy function. And if you activate here the HTTP proxy function, each time I would now request a call, I would see the request in that part of the window, and I would see the response together with the data package coming back from the SOAP system here. I'm not showing that live because it would expose all our passwords, so sorry about that. But that's how SOAP UI really helps you to drill down into web services the same way Swagger does. Back to the SOAP application, modular input version 1.0. So the application has two components. The first component is it stores our username and password. And if there are multiple usernames and passwords, there will be multiple entries. And we will have the data inputs on the other side. The data inputs you will see again. It's again the WSDL name together with what the application name is. And then if I click on it, you will see pretty much the name of the WSDL. So you have to copy the WSDL on the server. Then you need to tell the SOAP operation. We had to write an error handler. And that is pretty much the request criteria. That would be the request information coming in the SOAP UI on the left side, what we are sending to the system. Authentication here means there is a username and password, and the password is stored in the SOAP app. Then you can say a timeout as an error handling, how many packages you wanna have. And the most important setting here is polling interval, repeat that call every 60 minutes. That means from now on, once I have that SOAP call registered, the application takes care that every 60 minutes, the same call is executed again. And all those values, which are in the request field, are automatically updated to 60 minutes later. Then you pretty much say in which index, and there you go. I guess I need to speed up a bit. So let me show that one more time. So that was the STL part. So user activity is pretty much one of those views. And the other one, the SOAP one. Come on. Let me just show a few here. Account sign-ins unidentified. So let's use one. You can see Workday is extremely busy for 300,000 users. So, but it shows again, even it's coming in via SOAP and WSDL. It's still in a JSON format because that was our way we wanted to have it. What can you do out of it? And now I want to show you quickly one of the dashboards. That is the component you get from REST API. You pretty much can see where our users are coming in from. But the REST API, as you can see, also tracks integration users. And since all the API calls are done to the source of Workday, which is done in Ireland, you see we have 750,000 accesses in Ireland, and the rest are spread across the world. That was part of REST. For us, what was more interesting is what can we get in SOAP? And in SOAP, I can clearly see per country how many users are logged into which geolocation. And the guy which was hiding at the Seychelles is no longer here, so he must have returned to work. But for us, more important, we see, has a system account, an API user expired? Did MFA token expire? Did user use the wrong password? And so on. We can see, was it a web service, internal or UI based? Was it biometric, Okta? And then we can see pretty much the anonymized usernames, where they're coming in. Was the issue username, PIN, biometric, and how often did it happen? And that allows us, oh, sorry, it expired. So let's run it one more time. That allows us pretty much to give all the raw data required. Oh, yeah, now it's building. To our SOC for monitoring. But it also allows us, if somebody tries to log in 35 times and it's a real user, then he must be doing something wrong. So it also allows us pretty much to find out, is there education issue? Are there security issues? Are our manuals not good enough? Is there a way we can improve it? And
very cool.
Unauthenticated, well, glad we don't have any bad boys currently in the environment.
Nice. That was a really good view from one end to the other. We have only a couple of minutes left. I don't know if there are any questions.
I have a question. I'm Karen Cooper. I work with at MITRE with Eugene. So I just got a request to install the Workday add-on because we just it's so funny. I see you because we just moved over to Workday in the last year or so. I could actually see them maybe asking about, they want to see who's trying to hit stuff. Do you have an add-on? I mean, the SOAP that you actually created, the SOAP itself, right?
We asked Baboon to write it for us, but
okay.
But I think we can discuss what options are.
Okay. Can I get your email address and I can send you a...
Let me put my last slide back up.
Okay.
Because I think that slide might be handy, because I realized I talked too much. And I'm sorry there's not enough time for questions, but I'm happy to pretty much answer any of them.
Okay, great.
Yeah, we have the Boston channel and the Splunk Slack. So you can always find Marc there if you ping him. So thanks.
Okay, cool. Okay, great. I'm sure I'll be contacting you, Marc. Thank you so much.
Any other question? Sorry, it was a lot, but I felt showing it how it really can be done is the first way to get it done.
Yeah, very, very thorough.
Very good. Thank you so much.
Thank you.
All right.
Thank you, everybody.
Thanks.